Welcome to August 26th LeetCode Challenge. Verify pre-order serialization of binary tree. One way to serialize a binary tree is to use pre-order traversal. When we encounter a non-none node, we record a node's value. If it's a null node, we record a sentient value such as the string pound. So, for example, this binary tree here. Of the above binary tree be serialized as the following string. So notice it's a strings, comma separated value, and we have pound signs and numbers in there as well. But they're all strings, where a pound represents the null node. Given the string of comma separated value pre-order, return true if it is a correct pre-order traversal serialization of the binary tree. It was guaranteed that each comma separated value in a string must be either an integer or the character pound or hash. Representing the null pointer. You may assume that the input format is always valid. For example, it can never contain two consecutive commas, such as comma comma. Note you're not allowed to reconstruct the tree. So we're given this pre-order string array, and it returns true because that's the tree that up here that we're given. So that is in pre-order traversal. So it is a serialization of that binary tree. However, this is false. It's pretty obvious because you can't have one then null. That's not a pre-order traversal binary tree. And likewise, you have 9 followed by null null 1. That's not a pre-order traversal tree. So the pre-order length is 1 to the 10 to the 4. Pre-order consists of integers between 0 to 100 and except by a comma and has hash signs in it. So basically, you just given a string and you want to verify whether it's a serialization of a pre-order binary tree. That's pretty much it. So pre-order traversal, meaning that you would keep track of the numbers traveling like this. So if it's a pre-order traversal, you would count the numbers first. So it'll be 9, 3, 4, followed by 1, followed by 2, and followed by 6. And the pound sign represents the null node. So for instance, 9, 3, 4, and then it's supposed to have 2 more null nodes at the bottom, but those are null, so it'll be pound, pound, going all the way to 1, pound, pound, going to 2, pound, 6, pound, pound, and that's it. So that's how we do pre-order traversal. So starting from this, you count the number first, and then you go down, then you count the null nodes as well. So in order to do this, I'm going to do a, what you can do is actually a reverse traversal. So you just go backwards and kind of analyze whether it's valid or not, and using a stack to keep track of the string. So let's do that. Let's see if that works. So stack, we're gonna make that empty. Make a stack. And then we are going to parse up the pre-order string because we don't want this just comma separated value. We just want the number of values in there. So it's going to be we're going to reassign it actually. Just call it pre-order dot split via the comma. Alright, that seems like makes sense. And then we'll do a for loop in there to iterate through each element inside the values inside the pre-order split value. So for each index in the range of the length of pre-order, you want -1. You want to traverse it in reverse. Let's go backwards by 1. And then if the pre-order value at I is not equal to the null value, then what we want to do is check to see if the stack is less than 1. So if the length of stack is less than 2, I should say, then we want to return false because that's not a valid pre-order traversal of the binary tree. Otherwise, we would want to pop from the stack, right? We pop from the stack twice, because if the length of the stack is less than 2, that means that it's two. They need each empty node here has 2 null values, and the only way it could be 1 is if it has a branch like this. So I'm gonna pop the stack twice, and then we want to append stack. Append. We are going to append the preorder traversal at index I. Alright, so next we want to return a boolean. Return a boolean such that the length of the stack is equal to 1. Let's check to see if this is right. True. Awesome, accepted. So we pretty much made a stack. We traverse it in reverse order, and then we check to see the length if the value at the index I is equal to pound. If so, we're gonna check to see if the stack size is less than 2. If it is, you can't have that because it's not a leaf node. Therefore, we pop it twice, and then we append the index back to the stack, and then we basically we repeat the for loop, right, until we see the stack. And we return true only if the length of the stack is equal to 1. That means that there's always going to be 1 value inside the stack because we're traversing it in reverse order. Alright, and time complexity is big O of n, where n is the length of the preordered string. Space complexity is big O of n as well as the size of the stack, right? We could do this recursively too, but I guess iteration works well. Alright, that's it. Have a great day, guys.